as far as this experience. So make sure that you are just being you. Okay, so some of you I might have to still help out to get retrack, and that's fine. Okay, so hopefully, I'm going to give you 3 minutes right now on the clock. I want you to make sure your graphs are ready to be graded. I need you to get out 2 things. Stamp calendar and have it labeled, okay, for lesson 23. Go. How much time did I say? 3 minutes. I'm going to come around and stamp and evaluate your graphs. Go.
Okay, we got all our graphs done, right? Do you have them open?
By the way,
Do you want the document and we can enter
we
it?
have, how do I say this? Kind of modified the entire day.
I can't hear
Just when you will
you.
see modified. Good luck. Okay?
Oh. That one was shot.
No.
What we were doing? It looks like this looks like a weird thing. It was in my way.
Stamp calendars out.
Stamp calendar.
Which group's ready to go? I'll let you advocate for yourself. All right. All right, guys, freeze. We're going to be doing this a little more often as far as the checkpoints on the day after. So let's talk about how I want to teach you how I want to do these checkpoints. Stamp calendars need to be in a pile, ready for me to stamp. You're going to be getting an evaluation on if the graph is correct, as well as an evaluation on your effort with the graph. If you have 8 graphs, Camden, then you're going to be getting all the points, if they're all correct. I will be evaluating that as I go through and looking for if you've modeled these correctly. And then, Will, I want your group to go ahead and send me the graphs on a shared doc so we can use them. Yeah, but I probably deleted it.
Oh no, we're not. I was erasing my own graphs and put them on the 3rd sheet instead of the 2nd one.
Okay. All right, so go ahead and pull up the graphs.
At least you can access it.
Can you go to, that's okay. Can you go to Zoom 50 so I can see all of them?
I can't edit it because.
Same. I can't edit. Yeah, you can't edit. Did you turn it in?
Line of best fit, yes. Line of best fit, yes. Keep going down. Line of best fit, yes. And then where's your teacher's got to apply? This one's actually not right. See how you're at 21, 24. See how that? So you need to switch back to slide. I'll do the rest of it. Okay, so you get full. You uncircle or turn it in. You mean do you need help doing it? Is your question? Yes. And then delete the graph and redo it. Select from, you need temperature to be on the first part of the selection. No, because here's where, guys, I always forget about this class, sorry, honestly. Remember, we are behind, so we're only covering today, we're still on 24, sorry. So you need to write a college in lesson 24, and if I were you, I would just write the title that's in Google Classroom, which, what does it say? Graph what? What does the Google Classroom say? Lesson 23, graphing and analyzing 2 things. And
Condensation.
2 things. Read your graph.
Oh my god.
Temperature.
Thank you.
Temperature.
There.
Temperature.
Yours are all right.
We're only doing one.
You're only doing 1. You only get 1 stamp today. You need line of best fit. Oh, okay. Okay.
I can show you. I'm not sorry you teaching this class.
Okay, can you go to Daniel? Who's the rep for the graph? Who's the rep? Who's already got that? Okay.
Oh, so that means we should have beer going up.
What?
Okay, can you go up?
What the?
Okay.
All this eerie.
Okay. These 2 need to be, oh, you made that.
I'm thinking.
Hey, what rule are you not doing? What's the most efficient? What are you saying? Put the calendars in the what? Do it! You're done! Thanks. Okay.
No.
All right. Let's give you a couple minutes to finish up. Why did my timer not give up? So this is the problem with transferring classes. Can't plug in my speakers in a more efficient way. 30 seconds. Is there any group that I forgot about?
No.
No. Bonus. Who did? Naya?
Really far down. About 493 far down.
Okay. Let's see, go zoom out. Oh, you can't. You guys can.
Miss Angara, you wanna see a science trick? No, Owen doesn't.
How do people do that? Where they get steam?
Oh,
Two of yours are incorrect. Camden, are you ready to prepared and ready to explain the graphs? Because you're the person. You are a great speaker. So we are going to pick that. These are not. Okay. These you only selected. That's only one data point. It's only one period of time. You needed to do.
I honestly don't know what to do.
Okay, well then make a copy of it and edit it and then reshare.
So then try to talk this first, then that.
I mean, I don't know what to say.
Yesterday you tried helping her, but you said that she couldn't.
Yeah, but she needed to leave it, but then I wanted her to make the new one.
I'm trying to figure out.
And plus, you're a group, so you need to be able to distinguish the difference. Okay? Yes. So you'll need to see what you did wrong via, as we are reviewing that today. What you did wrong was you didn't do. Yes, you've expressed that to me.
Well,
So you need to
trying
make,
to figure
go
out
back to your graphs.
why the population changed.
If you follow the directions had all the different graphs.
Wait, I think I'm
Trying
gonna
to
find
figure
a
out
lot of
the
editing.
data for
Guys, a couple of you guys are running into a couple of different
changes
hiccups
in the environment. and we're trying to
because of the
figure out,
fact that
like,
you
if the
relied on
rain
each other.
affected it,
Again, this is
their
group work.
population changed,
So-
or if the precipitation.
No, it's good for being where
All right,
you're.
the year's 2000.
Okay, so what's
You should end the year, should you get it mentioned 60?
Yeah.
average annual?
So with the
Right, that's frustrating.
scattered
No,
floods,
it wasn't
Minimum
Yes.
rainfall right now.
Average annual rainfall, this is incorrect.
trying to figure out the consistency
So
of
this is
like the
65 through
rain per
75.
year.
Oh, her
between
graph,
1960
no.
and 2000 and
You,
precipitation
yes,
per year.
because you couldn't figure out how to modify your scales. That's right.
Whoever's
No,
doing
your
the
graph
Well,
is
we
right.
don't
No, no,
know
no,
yet.
this-
Check, check, 1, 2.
It's only 40.
Yeah, this is right. Yep, you're good. Keep going. Yeah, her scales are all off. That's what you're saying.
Well,
You guys
Check,
have full
from the
points.
year
check.
You're all
1960
correct.
to
Your scales are off.
1980.
Does that make sense?
Check, check.
So there
Liam,
might
you
have been
good?
like a,
Also,
okay,
where's
amount
our-
of
Where's our overall
precipitation
average
and
temperature?
stuff like that, but
Here, I'll just erase it.
between
Okay, Landon, can I have,
1981
can you
and
erase that?
2000 started to
6 out of
decrease.
10, put a 10.
So
I'm 7 years old,
the
Can you
environment
please give me the
changed
ability
might have
to?
been too much for
You
buffalo.
can feel that one, Landon,
So-
right there. Borrow
Yeah,
that.
but it does take away my.
Okay, what's the, where's my stamp? Who's my rep?
Yes, you're gonna see a science trick.
Okay, who's my rep?
It won't be
Go
that
ahead.
hard. All you have to do is just click on the graph and change it so it doesn't go from 10 to 2000. It just goes from 1960 to 2000, or about 40 to 39 years.
You
Okay.
should ask him to
I
explain
can
it.
play
He's
the
really good at
game.
explaining.
All right, go down, go down, go down, go down.
I don't, I will win.
Good, 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 good. And excellent, excellent. Nice work, gentlemen.
Did you see that though? I didn't watch this whole thing.
All right, perfect timing.
I'm famous.
Hopefully at this point, everybody's got your lesson 1, or lesson 24, excuse me, ready to lock and load, okay? All right, our question still that we're trying to answer is changing buffalo size affected by rainfall as well as precipitation? Now, I have a question for you that I hope most of you will be able to evaluate. We're gonna evaluate together today to make sure we're getting there. Okay, we're just gonna open up Alyssa's because hers is already here, plus you don't know her anyway, so it works out. All right, let's go ahead and evaluate your graphs. As we are evaluating them, I want you to think about a question. The first question I want you to evaluate is this. When looking at, pull them up, when looking at your average temperature graph that you guys created for the entire scheme from 1960 through 1920 and 2000, and evaluating your graph of average rainfall, not just the breakdown, I want you to look at both main graphs. We are answering the question today of the correlation between buffalo. Now, I'm going to ask you to help me draw this. Most of you have this picture memorized in your head as far as data. 1960 for buffalo population, what happened to it? All the way till what year?
1975.
Thank you. Then what happened to it?
It went down.
Till what year?
2000.
2000, basically.
1999, it went up.
98.
Okay, and then what's it starting to do again?
Wait, it went down more than it did in 1960. It went down more than it started.
Oh, so I think that's right. Go check for lesson one, Will, if you feel like you need to correct me. All right, so what are we trying to solve, guys? We are trying to solve if two things, precipitation and what? Temp affected. Okay, let's look. Let's prove it. Camden, lights or Marcos lights?
Wait.
According to this chart, where is the highest temperature?
2000.
2000. That means at the very peak of what we're seeing, what are we seeing over a period of time to climate? It's getting hotter or colder?
Hot.
Hotter. All the way up to what year? 2000. Is it still hot at its hottest point in 2000? Yes or no? Yes. Therefore, is there a correlation between climate and Buffalo? Think about this. I want you to look at this data piece. I want you to look at this data piece, and I'm going to give you 1 minute on the clock to discuss and come up with a group answer. Go.
Well, we're not
It's
much-
not.
Is temperature affected by, or is Buffalo affected by temperature? Go. 1 minute. Will, you can't answer it. No. Talk about it amongst your group.
It goes down much farther than 1960. To a point that the incline is even bigger than 1960.
As the temperature goes
Help me
down,
out here, Will. What's your question?
Lower down. Not that far down.
the population decreases.
Yeah, like there and then up. Yeah, like that.
Wait, it went down
Around that.
So maybe.
Right. This is an estimation. You can look at the actual graph. There you go. Perfect. Thank you, Will.
I think
Samuel,
that's
what's
like,
your fancy?
Gavin, even though the line is going straight upward, it doesn't mean that the data being showed. If it's showing a colder temperature, that means that like it goes to a certain point where it reaches a maximum warming.
Okay, what's your discussion here?
You
Does
feel like this-
temperature affect the
There's a certain amount of
Buffalo
water that a
population?
person's drinking.
Maybe.
They don't get
What-
enough
where do we get
to
maybe
survive
from?
more
Let's
than
look at
they
a graph.
get. There's a
You can
certain
pull up
part
your
where you start
accurate
to
graph
die
if you want to, but you need to look at your actual graph for temperature. Sam has it up. What is he
So
noticing
what's
with
your
temperature? What is it doing?
That
Increasing. The average, your line of best
the
fit is
middle
what?
area is
Increasing.
around the right
What happens to
temperature
Buffalo?
and anything colder is too low,
Increase,
or anything
then
above
what?
is too hot.
Therefore, is that a factor?
Okay,
All right, we're gonna do a quick little assess to see where you're at. Thumbs up if you think that Buffalo population is affected by temperature. Now listen, according to your data. You can't just basically come up with these pre-existing knowledges and then just go with it and say, I go with it because I'd go with it. Okay, you've got to be specific and be able to what? Prove it. Okay, you guys say that phrase all the time to each other. Prove it. Okay, well then actually do it. Okay, so two things. According to the data, thumbs up if you think it's affected it. Thumbs down if not, and I need you to be able to defend it because I'm going to call on you whether you vote or not. Thumbs up if you think it's affected. Thumbs down if you don't think climate affects Buffalo. Go. 3, 2, 1. Vote.
Wait, do you mean like thumbs up if we think that's the sole purpose?
Okay, Jake, I'm going to ask you to defend why you think the Buffalo is being affected by climate. Okay? That has nothing to do with it. Will. Jake, why do you think? Let's try to prove it together. Okay? I'll go back to the data
Okay.
so you can view it and have something to talk about. This is not the same one. I have too many tabs open. There we go. All right. Okay, Jake, go ahead and tell me why you think that these two have a correlative piece together.
Well, because if the temperature increases, or when the temperature is down more, so towards the end, that's when the buffalo population is increasing.
Okay, may I interrupt you? Fast forward to 75. Is it hotter than it was in 60? Yes or no?
Yeah.
How do you explain the peak then? Just a question. I'm
Maybe-
playing devil's advocate. Okay?
Because maybe that was like the perfect temperature for their like food source to grow.
But I'm giving you the data.
I
So,
don't know.
right, no, but Jake, it's okay. Again, you guys have to start accepting that it's okay to be wrong. We just have to prove it. So, is there a correlation, yes or no? The answer is what? No. Why? At the very end, when it's the hottest, Will helped me over here. Is our buffalo population still trying to climb? Now again, yes. Okay, let's look at rainfall. Same question, guys. Same question. Let's evaluate average rainfall. And the nice thing is that this is separated. I don't want this separated. Okay. What is happening to average rainfall throughout the 40-year period? Increasing or decreasing? Decreasing. Decreasing. By what?
Not very much.
Not the whole lot, right? But look at it, is it decreasing or increasing? Okay, evaluate this. In 1975, is it decreasing or increasing at this point? A slight decrease, right?
Yeah.
What happens to buffalo? Do they skyrocket down over the next 20 years? Yes. Is this, talk about amongst your group, 1 minute and 30 seconds. Do you think these two have a correlative piece together, or are they unrelated? Go, talk.
Unrelated.
This one.
Because the water goes down at a constant rate the whole time in both graphs.
What do you think, Will?
It's not related. The rainfall to the buffalo.
Does it have a direct correlation or not?
Well, I mean, no, because it goes down anyway, even in the
Because that one goes on steady, but that one
So what's our evidence?
The fact is, there's no evidence, that's how I can't prove it. There's no way to prove it.
But no.
So why?
No, it does not, because when you look at the full thing, it might show that it's going down and increasing. It could be that halfway down, it's
Daddy
still
Jake, what do
going
you
down.
guys got over here?
But when you look at both of the
well, I
two
know.
If
separate
rainfall's
sheets from
decreasing, do you think
first
that's a
20 years and
direct,
last
do
20
you
years,
think there is
it's
a
still
direct
going down at a
relationship
constant
for
rate
why
all the
this
time.
is a peak in
No.
spike?
I think the
Not
temperature is
really,
more
because
related to the
it's
loss
not
of water than the temperature is related to the loss of
So,
buffalo. Same with
It's,
water.
it's kind of
to the
decreasing at a
loss of
steady rate,
heat
while
and so on.
the buffalo are just dropping.
Right, plummeting, that's a good point of that. Okay, good.
Almost extinction. Oh, no.
Did you guys do something?
Okay, what's your guys' hypothesis? Related directly? Do you think there's maybe an indirect relationship? Yeah, but do you think there's no direct? Why? Right, so, oh man, I don't have it up. I'm gonna pull it back up in our time. Well, our time can expire. Are you guys here with me? Nine.
Hey, bro, watch your jet. Watch your
Okay, so what you gentlemen are saying is this slight decrease is what? Not affecting your what?
Oh my god.
Your overall, yeah, the population. All right, let's bring it back together, okay? I'm gonna ask two groups to share out. I know you guys have had some time to talk about this. So first off, let's do a reminder for why we are looking at graphs. What are you guys gonna be taking in approximately 2 years from the date? The ACT, yeah, you're gonna be taking the ACT. So part of this is to understand a better understanding of your graphs. Okay, so I thought this group had a pretty good conversation. Did any of you four want to share out for what you and why you thought what you thought? So direct or indirect relationship? Okay, why do you think that? What is your analysis of this graph? What's rainfall doing? Okay, now let's elaborate a little more on that. You guys built this monthly rainfall, and you built a line of best fit for it, aka what does Google call it? Trend line that we discovered?
Yeah.
Trend line? Okay. So on this person's, I can't really see it, which is why I suggest changing the color. When you get to really advanced levels of biological statistics, you'll actually have to leave it the same color, but we're not there. So this is almost what? Level. What do we call that? Starts with a C. Constant, right? Now, I want you to take yourself out of Serengeti right now and apply it to Nebraska. Do we see with like sandhill cranes and rabbits and all of what's found in natural predators and prey of Nebraska, do they survive at about the same rate every year with those factors, some of which are changing? But are they able to survive, yes or no? Yes. Why? Because of things like this. Level is consistent. That means, I know sometimes we think the winter is like super awful for animals. There's still natural ways that they're able to find water. That's proven here. You guys proved that all the way down in Africa. You could easily prove that all the way here in Nebraska. Okay, so let's build on this. Please open up your doc to lesson 24 right here. You should have the student activity sheet. We just answered question 1 and question 2. I'm going to now ask you to predict. Okay, so what I need you to do is I need you, when you open up this doc, to go down to the prediction. We have answered why. Now, I know you don't know this, so you'll have to reflect on it when I give you time at the end or this evening, but we've answered those two. So now we're going to start at investigation 1. Click on the nature.com article. This article to life what you've already studied. We've already looked at this. This was had the word capture in it. What do we talk about the word capture? What do we talk about capturing? Are we catching them in a cage, or what does the word capture mean with this limit?
Picture, video.
It means what? Yeah, pictures. Okay, we're collecting some data or data. Good. So what you're going to do here is I want you to make a prediction for what you think based upon number of captures, and I will allow you to use Google. What is the number one prey versus predator relationship with comparison of buffalo to who do they get hunted by? Okay, so come up with that. I'm going to give you a minute. We'll do a minute 45, and I want you to, no talking, I want you to try to solve for it by yourself. Go.
Where's the name of species of buffalo that live in the Serengeti?
So we answered.
Number 3. 1, 2, 3, but you're only working on,
I don't know.
oh, okay, perfect. Okay.
What's the name of the subspecies of buffalo that lives in Africa?
Oh, so number 3
I
is
don't
then
remember.
prediction.
It's called the Cape buffalo. Got it.
Yeah, I don't remember. Sorry, Will.
Got it.
So again, you're trying to investigate. You're on number 3, investigation 1. What is the number one species that is hunting for buffalo? And then go and type that. Number 3.
Wait, so
So look at captured pictures. Yep.
so we just proved that precipitation and temperature have nothing to do with it.
Correct. How did you prove
So-
that? Because what did you notice with temperature? Is it on the decrease or increase? Constant what?
Seems to be the
Constant
lions.
increase.
Constant increase. And what do we notice with the population is even though temperature was doing what?
Even though temperature was increased,
I did your best.
Correct. Good. And then what about the opposite with rainfall?
it was decreasing at a constant rate. Decreasing at a higher rate.
Higher rate, and they were also at one point increasing even though rainfall was decreasing. Very good. Good job.
Yeah, but
That's
we're
what we
at
need
the
right there.
question.
All right.
Investigation.
Let's try to say it together, and you might have more than one, but let's try to say the main one together. What hunts buffalo? 1, 2, 3. All right, let's see it, guys. We gotta see if we're right, though, right? That's like the purpose of science. So let's go to a live stream. I mean, it's not live. All right, sorry.
Ninja versus no nature.
I think a buffalo's hunting the lion.
No, the buffalo's being hunted.
Now, this is a male buffalo, as you can tell, but I'm gonna point out something else, and I'm gonna be stopping and starting it so you learn extra, because why not? Okay, what? I don't want all that. All right, so what is this? Could we hit the lights back there, Marcos, please? The other one? Yep. Okay, what is this on the back right here? I want you to kind of get to a prediction point of, hold up. I want you to just think quietly in your head, what do you think that is? Is that a birthmark? Is that scarring? Is that, now this is a male, okay? So I want you to hypothesize, and then I'm gonna play. Here we go.
Reading your
Okay, now I want you to close your eyes. I want you to picture from what you know currently about lions hunting buffalo as the number one, okay, predator-prey relationship with what hunts buffalo. I want you to picture, close your eyes, I want you to picture how you think this scene is going to end and come up with a reason for why. Close your eyes, picture it, come up with a reason for why. Okay, now let's see what happens. Try not to just focus on the scene. Try to soak in everything that you're viewing. most of these are females and then some young juvenile males. Okay, now, Will brought up a great point. Will said he doesn't seem to care, and I want you to try to come up with this observation piece. Where is the buffalo most defensive of on his body? Watch his behavior. Figure out where is he most defensive of. Watch his behavior. Is it his back? Is it his feet? Is it his chest? Is it his face? Figure out, number one, where the buffalo is most defensive of. Try to figure this out. Now, you're bringing up another great piece. Why is he not fighting? What does fighting need?
Energy. Just letting them wear themselves out.
Great hypothesis, Will. Good.
How are they not training? Not thick skin, take an insult.
It's called hide. It's what leather's made out of. Now, is he facing some pretty severe tissue issues right now? Yes.
There's no nerves in that part.
No, there's nerves, Will.
He's still just chilling, dude.
Okay, now quiet. Okay, now, freeze, Langer.
Yeah,
Okay, now,
They have cherry pie inside of them.
why would we show this in our series? Now, I want you to think, this whole unit is focused on what? Ecology. That's the study of how everything ties together. Now, I want you to view this. Now, I want you to see this. These right here are thorns this big. Okay, now, some of you are thinking that's not exactly accurate. You'd be right. I'm not sure the exact measurement, but you can tell structurally they're pretty large. Watch behavior.
It's not playing into it.
He's gonna run into it.
Go for the udders.
Laura dice que es un morder.
Oh no, it doesn't.
African.
What did they say?
What's the bull protective of?
Face. Neck.
Watch when he twitches every time they touch it.
Leg.
Legs, good.
No, no te vayas.
Yikes, that one's gonna hurt.
Stop pinching.
Do herbivores protect herbivores? Carnivores protect carnivores? I want you to kind of think about all these systems. Think about the food chain. Start getting that in your head.
I want to pet it. I know it has blood on its face, but I want to pet it.
Okay, guys, quiet down.
No, pushing buffalo for a lot.
Why will this? Watch this. Think about why this theory would. Why would this tactic work? No, I don't want the answer. I want you to watch and figure it out.
Is he in it?
He's inside a thorn bush. Yep.
This is my phone.
Sí.
Why would that work? What do the lions not have protection over?
Their eyes.
So what would potentially puncture them?
Their.
A thorn. Now that's the call of the wild right there.
Is that a cat? Simba.
I know it's in Spanish.
Now, will he survive? We're unsure of. Hypothesize with your group what you just observed and how that would reflect to the answer to your question on number 3.
Spanish like I understand.
I think at the back of him is like that brown piece of silver, like extra thick or extra no part of his hide. They didn't actually need, but was just kind of there. It was like
like, so that way they would be worn out and they wouldn't be able to get them once they hit in the thorn bush because they'd be too tired to maneuver
Okay,
around
we're
the
supposed
thorn.
to be hypothesizing.
About a minute left to, keep maintaining that
Small for the
conversation.
entire size, so that means there's only a few tendons snapped. I think we'd be able to move them.
He fought
He
him
did
up.
have a pretty thick neck for a
There.
thick boy.
I don't
I think it was where I was trying to wear out the, I think it might have been like wearing out the lions so that way they couldn't attack next time. It was one of the many things.
It's their
Also, isn't it because lions don't have eyes, they have brains?
It's gonna be so long.
Don't lions not have eyes?
They don't really have much thick eyes, they just have skin like we do. All right, guys, let's go ahead and process this. Hopefully you came up with a group answer. I'd love for you to share them out. So I'm gonna kind of call on you. We'll go in order. We'll go 1, 2, 3, 4, and 5. Then we'll do reverse for our next activity. If you need to reread the question, it's up here. I'm going to read it out loud to you so you can hopefully answer every piece of the question. It says, now that we've learned and determined that the predator to the study is more in depth, what do you predict is happening to the lion population between the 60s to 2000? And many lions do you think are between 60s to 75 and 2000? And why do you think that? Okay, so make sure you're answering each of those different pieces to the question. So Landon, first part is, what do you think is happening to the lion population between 1960 to 1975, and why?
The lion population is decreasing.
Okay, and you're making the hypothesis because of what?
Because it increases the buffalo population.
Okay, then next group, I'm going to have you give your, and again, you don't all have to have the same answer. And this is why we're going to figure out the answer to this. Okay, Marcos, can you share out what you think is going to happen between lion population between 1965 and 1975, excuse me, and 1998?
The lion population will increase.
What's up?
The lion population will increase.
Okay, because you're saying that the population of buffalo is decreasing, so amount of feed is what you're kind of going with. Then Lacey's group, can you hypothesize what's happening between 98 and 2000? I know it's not a big spread of data, but it's okay. Go ahead. A little bit with the lines. Okay, so I think that those are decent hypotheses, and your whys are good. So what we're going to do is I'm going to walk you through an activity. We're not going to run this activity for time's sake. I'm going to teach you the different parts of it, and then our main focus today is investigation 3. What investigation 2 is a study of what we could have done today is we could have gone to a DICE website, but for time, we're going to push a little bit faster. So I want you to hypothesize. I want you right now to get out a piece of paper because we couldn't figure out how to highlight on Google Docs. So I want you to get out a piece of paper, and I want you to, and it can be just scratched. You can do one per group.
Yes.
I want you to just make a basic chart with these things labeled. Atmosphere. Okay. Ending with soil. And again, you guys can share this because you're just going to need to talk about it. Okay? Then you're going to have grass. I'm going to give you guys a little more time, sorry. Buffalo. And lion. And then if you can just grab a pen and a pencil or just do different shapes. I'm going to use different colors. You guys can just use different shapes. So if we were to have ran this, you would have rolled your dice and you would have kept track. Math tells us that this is the probability for the answer. Okay, so yesterday I felt like we worked so hard with making those graphs that today I think we're just going to talk about it and then I'm going to make you do it on investigation 3. So what we're going to do is you're going to be comparing right now, live, we're going to be comparing these 3 things, chemical, motion, and heat. Now I want you right now, just kind of get your head going around this because most of you have probably seen graphs like this before. Tell me which of these uses the most what we call thermal energy, so heat energy. I want you to go ahead and hypothesize. We're not going to make 2 graphs. We're just going to model them on the same graph, but we're going to use different colors. Okay? So I want you to hypothesize which one of these, so this is the graph we're filling out right now, amounts of heat. Okay? I want you to talk about which ones are going to be using the most thermal energy. Just make a prediction. Go ahead and draw it on your graph, and then we're going to go over it. Yes, sir.
I've been looking into it, and I was looking at the trend of companies, and that's when I was seeing some trend.
I know.
Okay.
That's interesting, Will. That's interesting.
Five layers that capture
The buffalo, I'm already on.
No, you're not. You're just making a general graph. Because I couldn't figure out, I tried to figure out how to highlight big sections of that chart. I couldn't figure it out. So this is our modification. Yeah, I know. We gotta actually do paper. Are you gonna be able to function? Okay. All right. Guys, what do you think grass is?
grass.
Green.
Think it's pretty high or low? Why? Why would it be?
It uses,
But what does it collect?
sunlight to grow.
Collects it. Nice.
Okay.
Okay, it's gonna store energy. What do you think about buffalo? Middle range, lower than grass, right?
Yes.
Okay.
Buffalo.
So if you want to, if you're doing different shapes, you could do this again, and then we want to label this what?
Walk.
Okay. What do you think about lions? You think they're going to be greater than buffalo or less than buffalo?
Less than.
Less than quite a bit, actually, according to statistics.
They use food energy.
And what about soil?
It's probably like up there, higher than it's just maybe a little bit.
This high?
Yeah.
Yes.
Buffalo height? Lion height?
Just a bit
In
over
between?
buffalo.
Predictions?
Over buffalo.
Daisy nailed it.
Soil isn't.
What'd you say?
Oh, no, she didn't. That's okay, you were close. Okay? Soil energy actually falls right in the middle of both lion and buffalo. Kind of an interesting fact, but why do you think that is? Is there, first off, do most critters that live in soil, are they warm or cold-blooded? Are they a factor then? They're cold, so not really, no. Okay? So again, that's kind of part of it. Okay, let's do the carbon. Carbon atoms visited the actual pool of species. We'll do green for this. Okay? All right, make some predictions first in your head. I'm going to give you about a minute to make a prediction.
I think
Carbon is, isn't it the most?
I don't even know what that is.
Material in the
Oh, it's
carbon.
right. Oh, atmosphere. It's right up there.
I think so.
Did you figure out how to draw? No.
And then grasses is probably
I have not made my own.
Lacey's
like
doing your
down
group one.
here.
Omar's doing your group one.
Buffalo down
Okay.
here. Lions way down
Grass
there.
probably
Soil.
uses.
All right, what do you think about carbon in the atmosphere? High or low?
High.
Yep.
It's high.
Okay, yeah. Oh, it beats grass. Yes, do it with the pen.
I put it in the middle. I don't know.
What about carbon in grass?
Probably pretty high.
Okay, first off, what do we breathe in?
CO.
Oxygen. What do we breathe out? Carbon dioxide. So your prediction is, what do you think the amount of carbon is in grass?
Half. I put half.
Okay. It's actually about the same height, but it has no correlation. This is just. We're splitting the graph because it's easier for me to draw. So these are totally separate. So don't ever compare them.
You don't
Okay.
need to put that.
All right. What about buffalo carbon?
High.
Higher or lower than the amount of heat?
Lower.
Lower. Okay. What about lions?
I would have
Carbon.
Higher. Higher.
Pretty similar to buffalo, but not quite because they're smaller animals.
Wait, what?
Because
Okay.
they eat meat, so they get the carbon from the air.
Correct.
Okay.
And then soil.
Probably quite a bit.
It's about the same for both, which doesn't really matter, but it's higher than what do we see? Sorry, it needs to be higher
Higher
than.
than the lion.
It's higher than buffalo, higher than the lion, but a little lower than what? Grass.
In the
Okay,
atmosphere.
so again, part of this, let's go ahead and look at the questions
Nice
then.
spin.
Question number 1 says, when you have completed the playing the dice game, which we just did via math, okay, so number 2. The law of conservation of matter states that matter cannot be created nor destroyed. It can be what? Transferred. Underline that word. How does the simulation of ecology reflect the law of conservation of matter? I want you to discuss this. This is the question we are ending on for today. 47.
Wait, so,
No,
2?
we can finish till 4. Sorry. Okay, we're gonna end with these 2 questions. Your job is to analyze these. Right now, I'm gonna give you 2 minutes to do this as a group. You need to analyze how this carbon and heat, the law of conservation of what? Energy, matter, is gonna do what? Affect both the what? Buffalo and lion population. Try to solve for that. Answer question number 2. 2 minutes on the clock. Go.
How are simulations? Okay.
Heat is used more by producers than by consumers. And it seems consumers all take carbon from each other. And they all have lower than the first one.
Okay, so to get you
Buffalo
started,
takes about half the
I want you to
carbon from
think
the
about
grass,
this.
and then lion
So
takes about
what
half the carbon
is
from the
a
buffalo.
way that you are
Soil is
noticing
really
the correlation
unrelated.
between,
Because most of the carbon that grass gets is from the atmosphere, so you take about half the atmosphere carbon, and that's what you get there.
well, voice flexion down, sir. Thank you.
Yeah.
Thanks for all the answers,
Always can count on
Okay.
Appreciate it.
So what correlation do you see between carbon? So what are you noticing is happening on this between atmosphere, grass, buffalo, lion, and soil? What is the correlation that you see? What correlation are you noticing?
because they can't make it.
Okay, so you're trying to process what correlation are you kind of getting an idea of as far as what pattern that you're looking for?
Oh, it's also
We know that
the grass
the
is.
buffalo is receiving the grass and soil is
They were kind of biting his bottom, yes.
and the buffalo.
Different parts.
That was
They're getting
strong.
their just in the atmosphere.
From a previous attack,
I
right?
got you, buddy.
So my man tried to talk twice in one lifetime.
I got you.
Yeah.
Buddy.
So again, how do you see that this is an ecosystem issue, not just a specific issue to those 2 species? What are you noticing with carbon? What are you noticing with carbon?
I'm a Tuesday.
Yeah, you're seeing the correlation between the 2.
We get it, you're good.
All right,
Investigation number 2.
guys, I'm gonna give myself about 3 minutes to finish up with this one. Did we see 2 probe questions for you is, I want you to think about this, okay? In the simulation, was energy ever created? No, what did you see that it was?
Just the atmosphere.
Well, guys, look at that, to the heat. What are you seeing, what are you seeing that's, what are you seeing it's doing? It's transferring, right? Because why would I ask you a question about something if we weren't going to use it? So you're seeing the energy transfer through the what? Different what? Parts of the environment, specifically leading into the food chain. Okay, so what are the 3 that we talked about? Chemical,
Motor, I don't know. Chemical, motion,
and
thermal.
thermal. Okay? So when you're looking at these, you are going to be able to see that this is a correlation. So let's go to question number 3. The law of conservation of energy states that energy cannot be created nor destroyed. It can only be transferred. So this is a simulation in ecology reflecting the law of conservation of energy. Yes or no? Yes, because it's transferred through those types of what? Energy.